Pain is the transformation of chemical, mechanical, and thermal sensory inputs into a subjective awareness of being in pain. Pain can induce a fight or flight response. It can also inhibit behavior to promote healing. Pain is an actively constructed experience, which means that expectations, beliefs, thoughts, and emotions all have major influences on pain perception. In majority of people, pain resolves as the injury subsides within a normal healing period. However, in a minority of people, pain persists. So why do some people get complete resolution from pain while others suffer from pain for decades and years? The answer to this question is complex and not yet fully understood. Up to about 20 years ago, pain researchers studied the site of injury, spinal mechanisms, or inflammatory mediators to find answers to this question. However, with the advent of neuroimaging studies in the last 2 decades, we have a better understanding. Neuroscientists argue that the functional and anatomical properties of the brain predict transition from acute to chronic pain with about 80 to 100% accuracy. They further argue that the corticolimbic system mediates the transitioning from acute to chronic pain. The corticolimbic system, which is made up of the prefrontal cortices, amygdala, and hippocampus, processes a broad range of behavioral and cognitive functions, including motor programming and control, decision-making, and emotional regulation. The overall function of the corticolimbic system is to preconsciously assign value to the environment within which the organism exists. In susceptible individuals, transitioning to chronic pain depends both on the pre-existing limbic circuitry and the reorganization of the cortical limbic system following the inciting event. In other words, when an individual has learned to assign emotional value to pain, it may lead to cortical reorganization, which may in turn lead to persistent pain. The net effect is the brain that filters emotions, actions, and rewards through the lens of pain. Essentially, the brain has become addicted to pain. Evidence for the corticolimbic hypothesis is accumulating at a convincing pace. For example, it's been shown that functional connectivity among the components of the mesolimbic system mediate the successful self-regulation of acute pain. For another example, a moderate quality longitudinal study has established the functional connectivity between the nucleus accumbens and medial prefrontal cortex accurately predicts those individuals with subacute back pain who develop persistent pain 1 year later. Neuropsychological research also provides support for this hypothesis. In a model developed by Casey and colleagues, baseline depressive symptoms and pain permanence beliefs were the most powerful and independent positive predictors of chronic disability following an acute pain or injury. In other words, if you have depressive symptoms during an acute episode of pain, you're more likely to develop chronic pain than someone else who's not under distress. Going back to the hypothesis, we know from previous neuroscience research that the corticolimbic circuitry has a pivotal role in regulating affective distress. Furthermore, research has also implicated anticipatory anxiety, such as pain-related fear, as a strong risk factor for developing chronic pain. For instance, in patients with subacute whiplash injuries, pain-related fear and fear of movement were significant predictors of pain chronicity. We also know that the functional connectivity of the corticolimbic system has a central role in anxiety responses to stressful situations. So as you can see, there is some converging evidence implicating the corticolimbic functional connectivity and chronicity of pain. Further research is needed to combine all this information into a coherent model of pain perception that includes details of the system and molecular levels. When pain becomes chronic, it involves the entire being. There isn't one solution for all pain issues. There aren't any quick fixes that exist so far. An integrative approach is probably the most effective.